Welcome to AML Conversations, the Solution Series. This podcast series focuses on practical information about solutions to challenges you face in your financial crime compliance program. These solutions include managed services, technology, advisory, and third-party risk management. You can access this series and other AML Conversations and This Week in AML podcasts at our website, amlrightsource.com, SoundCloud, or wherever you get your podcasts.
Hello and welcome back to the Solution Series. Today, we're bringing back two incredibly talented individuals who have graced our podcast before. It's my pleasure to reintroduce Leandro Loss, our Principal Data Scientist, and Kevin Lee, our Director of Financial Crime Technology. Hi guys, and thanks for joining me again.
Hi Rachel, how are you doing?
Hi Rachel, it's my pleasure.
I'm good, thanks Kevin. In the previous episode, I asked Leandro a series of questions relating to the concepts and applications of AI to lay the foundation for our ongoing discussion. Continuing from where we left off, this episode is going to focus on a widely debated topic, the trustworthiness of AI. Many argue that it presents a significant risk to society. It's also often referred to as a black box, and I want to get a better understanding of this. Likewise, I want to understand why conventional white models are no longer effective in combating financial crime. So let's begin. Leandro, Kevin, what are your thoughts? Can we trust AI?
I do think we can trust AI as much as we can trust any other model that we have in our space, the FCC space. But I think that trust comes with some caveats. We need to put it within the framework that we as an industry have established over the past 15 years. And that is a framework that is anchored by model risk management, data governance, and all the principles that we have in place today that oversees models. At its core, AI is different than rules-based transaction monitoring, sanction screening, or FCC technology that we have today, because it learns, and then there's a level of learning from the output that doesn't happen with rule-based systems. And so I think in order to fully trust AI, we as an industry have to understand exactly the mechanisms for how the learning happens and ensure that there's a proper level of governance and the ability to control subjectivity in that process.
Leandro, what do you think? Can we trust AI?
I like the angle that Kevin took because there is a lot of debate online on if AI is going to take over the world, is going to become our overlords and exterminate humanity. And I think at this point, I think it's a valid concern as a human being, as a preservation of the species kind of thing. But at this point, I would tell you that there is more science fiction involved than actual facts. First of all, it's important because when we talk about trust, there's a strong connotation there. You trust your wife, you trust your husband, your partner, your co-workers. That's the trust you put on someone. And if they betray you, that's a life-changing experience, right? There's a trauma involved. That's not AI. AI is a machine. And as Kevin mentioned, it was trained to behave in a certain way. And what's special about the machine learning part of AI is that it's able to learn without someone explicitly telling them how to behave. So the way we've mentioned this before in the previous episode, that you give the input and you give the output. And the power of AI is to fill in the gaps, right? Connect that output to the input. And every time, or given a certain probability, you will provide that same output. That is AI. That's a piece of code. And as much as we talk about black boxes and stuff, you open the piece of code, it's a piece of code. And there are formulations, and they change the parameters according to the input to generate that input. So I just wanted to make sure that we're talking about the same thing here. We're not talking about the human side of trusting. We're talking about trusting the results of it. In that sense, it does overlap a lot with what Kevin said at some level, because in training the machine, training this model to behave in a certain way, of course, there are parts of the algorithm, but the algorithm is created by human beings, right? So human beings, you could ask, can I trust that organization of that group of people that are creating that data set, that training data set, to make sure that the data is unbiased, that the model is able to communicate when there is when it doesn't know the answer. So these two things, these two factors are very important: unmitigated bias and uncommunicated uncertainty. Because the model would tell you to make a left turn on the second traffic light. And it can tell you, hey, you can do this, and I'm 90% sure that that's going to take you where you want to go. That needs to be communicated. And so we can always look for this cues and, the history of the people working at that group, to answer that question, if you can trust it. So AI needs to be broken down into the algorithm, the techniques, the group that is actually developing that, and of course the political interest and the behind the curtain interest that in developing those, right? Again, addressing bias and uncertainties.
Absolutely. I agree with you, Leandro. What I think the question that trust is really getting at here is the trust of the bias or lack thereof of the individuals training the model. So, like Leandro said, machine learning it's not sentient. It's based on mathematic principles, maybe more abstract than a traditional rules-based system, but nonetheless mathematic principles. But there is a level of bias that is possible for training these models that you wouldn't really get in a rule-based situation. So I think we as an industry have to understand that and put it into the framework of model risk management and unbiased ongoing monitoring platform.
Leandro, I just want to go back to something you said there about AI being viewed as a black box. So how do we shine a light into this model so that it sort of loses that association of being a black box?
Right. So that's a great question. Because what is a black box, right? First of all, a black box can be black for certain types of people, and it may be completely transparent to a lot of other people that know a little bit about the domain. And we may not be talking about AI here, talking about going to the doctor. The doctor could explain in a certain language, what you have based on the symptoms you gave him or her. And you could understand if you have some expertise or some level of education that allows you to understand that, or basically you just get out of the clinic, remember that you have to take this pill 3 times a day. So it was a complete black box there. So in AI particularly, there is a set of techniques that involve neural networks. And these algorithms, what's so special about them is that they can basically grow to infinite, given that you have the right resource and stuff. That makes these techniques particularly black box. Not because, as I said, there is an algorithm that you can open the code and see, that you can't see all the parameters in each of those neurons, right? It is not about that. It's about our limitations as human beings to understand complex information, especially at scale. So most of us, we will learn, from 5 to 7, maybe 9 tokens of information at a time. Okay, so going back to Kevin's rule-based systems. Yes, you write a rule, but you're probably going to see that those rules are not bigger than, 5 parameters, 5 conditions. When you imagine now a condition that involves a rule that involves 200 parameters, 200 conditions, can you understand that? You can follow the path, but understand it deeply why this condition happened at the same time of this, or this one at 50% of chance of happening happens at the 75% of the other one happening. That's more complex. That's what particularly makes these techniques more black box. How can you shine a light, though? There are different techniques to do so. One that is particularly attractive to non-technical people is what's called the post hoc explanation. Post hoc, after the fact. So a machine, it doesn't matter how complex it is, it gives you an output based on that input. What these techniques of explaining the AI do is that they go back to the input and they start perturbing the input, trying to get similar or different answer from what the AI provided. And by doing this, statistically moving those weights around, it's able to determine that input number 1 contributed 60% to that output. The number 2, 30%. The number 3, 10%, and all the others, basically, you could have any input there that they didn't affect the output at all, which, in my opinion, is very similar. It's very attractive because it's very similar to what, for example, doctors do. You show up with a headache, and they're going to say, well, there's 60% of chance to be, this, and 30% to be this one, 5% and so on. It gives you, and maybe your ankle that hurts have nothing to do with that, right? So it's important to see that you don't need any knowledge of neural networks or AI. You just need to read the results from the explanation, and that explanation is given by the same language as the input, and input is basically in your domain knowledge. So if we're talking about AML, we're talking about the number of round dollar transactions. We're talking about having or not adverse media hits, being or not on a sanction list, and so on. So the explanation to that for that risk score would be, hey, round dollar transactions, 30%. Sanction list, 70%, because it's a severe thing. And everything else wouldn't matter. If you're on a sanctioned list, you would be a red flag anyway, that kind of stuff. So there are other techniques, but this one is really interesting for people that don't want to get into the inner workings of, as Gavin mentioned, the formulations, the mathematical formulations of a neural network.
Well said. Thank you, Leandro. I agree with most of what you were saying, if not all of it. I think the main reason why we view artificial intelligence and machine learning as a black box is because of the scale of complexity. The scale is a different level of complexity than your traditional rule-based systems. Traditional rule-based systems use a very simple if-then logic, standard arithmetic. But when you're talking about machine learning and artificial intelligence, you're getting into abstract mathematics, which some might need a PhD to understand. Others might need a master's degree or at least a refresher on the courses you may have taken decades ago. And for me, I think that is the crux of why machine learning, artificial intelligence is so different than what we have today. But it is very much necessary. As we've discussed in the past, Rachel, the 90 to 95% of false positives that we see today in TM and sanctions are not being used. So there needs to be some level of model feedback from all of this useful information back into the model to train it to make it smarter. And that is something that rules-based systems do not do well right now, and something that we as an industry are moving towards with the introduction of machine learning and artificial intelligence concepts. And to Leandro's point, the idea of machine learning is to use 50, 100, 1,000 different features in order to come up with a better answer than a rules-based system. One of my favorite analogies that I read on GitHub is when you're in a forest and you're looking for a mushroom to eat, and you see a mushroom, but it's a brand new species, and you don't know if it's edible or it's poisonous. But what you do have is a data set that helps you come to this decision. This is what is called a random forest model, and it's very popular in our space, which is classifying and triaging risk, typically in alerts or customers. So back to the analogy, the mushroom has a number of different features that you can use in order to predict whether or not it's poisonous. There's the color of the mushroom, the size, the odor, the shape of the cap, the color of the soil it grows on, et cetera, et cetera. And if you do have information about, let's say, 100 mushrooms that you know whether or not they're poisonous, and you know these different feature attributes, you can use that to build decision trees on subsets of this information. And with 100 or 1,000 or 1,000,000 decision trees, you're able to get a better answer on whether the mushroom that you don't know is poisonous or not. So that's just a simple analogy to kind of explain the complexities of machine learning. But I hope that is the sort of practical application that we're able to articulate as an industry in order to shine a light on the black box that is machine learning and AI.
In contrast to black box models, we have white box models. Their logic is transparent and the decision-making process is interpretable. Why are these models not effective in combating financial crime?
The answer is simple to me. I don't know if Kevin is going to agree or not, but the answer is simple. Simply because they don't work. For the complexity of the problems that we're talking about, the complexity of the skill set that criminals have today in understanding, using the system, understanding the rules that are set today, and bypassing those sometimes easily, more or less easily, white box methods based on everything we talked about here. Their size, the simplicity, the number of parameters that they use, the number of conditions that they can encapsulate and reason around is just too small. We're way past that point in time when we had problems that could be solved with a decision tree, simple algorithm that use few parameters. We're like Kevin mentioned, we're in the thousands and hundreds of thousands pieces of input. And if you think hundreds of thousands is not, you can't see that in ML, just remember that we're processing thousands of news articles for a given entity. So that as input, it's literally hundreds of thousands of tokens of words or syllables. So yeah, we're not too far from that. So white boxes, as I said, they're just too simple. Yeah, they may be simple. They may still be used to determine the entity type. If someone is a person, a corporation, if it's a casino, NBFI, yes, you can still use it. They still have room here. There's still room for them in our overall solution. However, when we're talking about adverse media, we're talking about sanction evasions, tax evasion, and we're talking about a different, a different game here, a different league. So I think going back to black box now that we said, simply that white box don't work, and some people could debate that. I'm open for debating, but the black box is the side effect of something, of an algorithm, a type of algorithm that is very much necessary. I paraphrased Kevin here. It's very much necessary. The fact that it's a black box, we're dealing with it. But tell me how the financial system can protect themselves, can detect, suspicious behavior when criminals are out there spending as much time as us when finding a solution. They're there also finding ways of bypassing the system. So we need techniques. We don't have much to sit with experts and say, oh, this guy did this, and now let's use these parameters. He has these 5 or 10 parameters to detect that new behavior. What we need is a system that is able to detect anomalies. First, it's detected as an anomaly, right? You have your rules, and when I say rules here, we're talking about patterns that you know of. You're talking about behaviors that are considered normal. And then you have an anomaly. That anomaly pops out in your system because it's just different from anything you've seen before. It could be legit, but it could be suspicious as well. From that, AI is able to say, instead of trying to figure out, ask humans to understand how that happened. No, it used the input and it says, this is suspicious. And all of a sudden, these rules, this set of patterns here in your neural network will change to adapt, to consider that not as an anomaly anymore, but as a behavior that was categorized either as legit or suspicious. So I think the black boxiness of these algorithms is just a side effect of a technology that is very much necessary for the level, for the volume, the complexity of our financial systems today. As I said, the volume, the scale of the problem is just too large for a simple decision tree or a set of rules to work. And Kevin brought that up very well. These systems are producing 95% false positives. And I, as I said before, I wouldn't like to come to my work just to find that 7.5 hours of my day were thrown away by just things that are not true. I would like to spend my whole day looking at actual crimes and solving them and, alerting on them and so on.
I'm relatively new to the industry, and something that has always stuck with me is how the bad actors are leading the innovation race. So you're ultimately saying that AI levels this playing field and that it's necessary because white box models are just too simple.
That is correct, yes.
Okay.
Absolutely. And I would agree with that. I think we as an industry and in our advisory business, we have the benefit of a broad view into the different typologies and risk coverage strategies of the largest banks in the world. I think as a traditional rule-based system, we as an industry are nearing our ceiling, if not already at it. And like you said, Rachel, it really is keeping up with the bad actors that exist, and they are the ones leading the innovation. And we have to react as an industry and introduce, I would say, more complex concepts in order to look for patterns and networking relationships between these bad actors.
Rachel, last thing, or let me add to that, just to make sure that this comes across. The fact that an algorithm is a black box, and as I said, black boxness has different levels depending on the audience we're talking about. But let's talk about in general. Should never be the determinant to use or not a solution. Because as I said, I point out one out of many solutions that try to explain a black box. And one of them has nothing to do with the technology itself. It's really completely within the domain knowledge of whoever is using it, which is this post hoc explanation. Just to make sure that this goes across. Never let anyone say, we don't use black box because we can't understand it, because maybe you didn't get to the point where you are really trying to explain it. Because if that's your obstacle, we have a solution for it.
Before we wrap up this episode, I just want to say thank you, Kevin and Leandro, for joining me again and for sharing your knowledge with us.
Thank you, Rachel.
Thanks for having us.
And to our listeners, thank you for tuning in. Join us next time as we explore large language models.
Thanks for listening to this episode of AML Conversations, the Solution Series. More episodes will be posted in the coming months. If you find this installment interesting, there is more great content at amlrightsource.com. If we can help you with your financial crime compliance needs, schedule a meeting on our website. Together, we can reimagine compliance.